area under the curve. So what is the actual mathematical definition of integration? Just like when we do differentiation, differentiation gives us a derivative, which is the gradient of the tangent at any point on the curve. Well, integration actually helps us find areas under the curve. So let's have a look at a diagram. Let's draw our xy axis. And if we have some function, f of x, in between x equals a and b, and we found the integral between a and b of our function f of x with respect to x, it would actually give us this area here is our answer. And the way we can think about it is that this area is bound between four things. The curve f of x, which is here, x equals a, which is here, x equals b, which is here, and the x-axis, which we can think the dx represents. So our integral tells us our four bounds which the area is enclosed in. So let's have a look at an example. Let's look at the integral from 0 to 2 of 2x dx. Let's draw a diagram to see what's going on. So we've got our xy axis, and let's graph y equals 2x. So y equals 2x, well, that's just a straight line going through the origin with a gradient of 2. And we've got the bounds x equals 0 and x equals 2. Well, x equals 0 is the y-axis. X equals 2 is just a vertical line going through 2. And dx, remember, we can think about as the x-axis. So the area bound between there is just the area of this triangle. We actually could find the y value here by subbing in x equals 2 into our function, and we'd get 4. And we could easily find the area of the triangle here using a half the base times the height. The length of the base is 2, and the height of the triangle is 4. And doing this would give us 4 units squared for the area. But let's see if it matches up with the integral. So if we found the integral of this, we'd add 1 to the power and divide by the new power, and we write our limits. The 2's will cancel out. So we just have x squared between 0 and 2. We sub in our top one first, so we get 2 squared minus subbing in the bottom one. 2 squared is 4 and 0 squared is 0, so we do get 4, and it matches up with our area that we found of the triangle. So here we can see that when we integrate our function between two bounds, it does find the area under the curve. Let's have a look at another example. This time we're going to do the integral of minus 2x dx between 0 and 2. So let's graph this one as well. So if we graph this one out, well, this is graphing y equals minus 2x. So this will be another straight line with a gradient of minus 2 this time, going through the origin. And we're looking between 0, x equals 0, which is the y-axis, and x equals 2, which is another vertical line. And so between the curve, the x-axis and those bounds, we get this area. So it's the exact same area because this y value is minus 4, so the height of the triangle is still 4, and we know that the area should be 4 units squared. And let's see what happens when we evaluate the integral. So we're going to add 1 to our power and divide by the new power in between 0 and 2. The 2's will cancel out, so this time we have minus x squared between 0 and 2. So we'll sub in our top one first, minus subbing in our bottom one. Now minus 2 squared is minus 4, and minus 0 just gives us minus 4, and we get minus 4 as our area. And it's important to see that we actually do get a negative, and if we're finding area, we don't want negative area, but what this really tells us is that if we have any area that's below the x-axis, we're going to get a negative answer. So areas below the x-axis are negative. So if you do want the area, you need to take the absolute value of your integral, which would end up giving an answer of 4. So in saying that, we've got to let's look at this one more example. Let's look at y equals x cubed minus 6x squared plus 8x. And if we graph this out, we'd have x-intercepts at 0, 2, and 4. And we get a curve that looks like this. And if we were asked to find the integral from 0 to 4 of x cubed minus 6x squared plus 8x dx, we can actually get asked two things from this integral. With any definite integral, we can get asked to evaluate the integral, or we can get asked to find area. So if we were asked to evaluate the integral, we wouldn't worry about any area being above or below the x-axis. We just evaluate the integral like we normally would. We'd sub in the values, and whatever answer we got, we'd just get. But if we're asked to find the area, we need to consider any area below the x-axis and make it positive. So in this case, the area that we're looking at would be these two. And since this area is below the x-axis, we need to separate it in the integral. So we'd need to double check, and then we'd need to rewrite the area as the integral from 0 to 2 of our function, x cubed minus 6x squared plus 8x. And we need to add it with the integral from 2 to 4. So it should be dx of x cubed minus 6x squared plus 8x dx. And this area here we need to take the absolute value of to make it positive. So it's very important to, when asked to find the area, you should probably graph it out if you can, and just double check if any areas are actually below the x-axis that you need to separate and make them positive by taking the absolute value. Because if you did both of these, when you evaluated this integral, you'd actually get 0, because these areas are actually the same, and this one's positive and this one's negative. But evaluating this integral for the area, you wouldn't get 0, you'd get a value.